quick revision exercise 6, which is about gradient. What is gradient? If the coordinates of 2 points are given, the gradient is generally we denote it by m is equal to y2 minus y1 over x2 minus x1. Means the difference between the y ordinates divided by the difference between x ordinates, or we can call them abscissa. Or even if you change the order, but in that case you will change orders of both numerator and denominator. Means y1 minus y2 over x1 minus x2. Commonly done mistake is the values of x in the numerator and values of y in the denominator. No, numerator consists of y ordinates and denominator x ordinates. Always keep this in your mind. From the two given points, the value of y and the value of x, starting value of x and y, those will be taken from the same point, and the second values of y and x will be taken from the other point, the same point. Say if I do part D, so in this case, what you can see is there are 2 points G and H. So if I will say in the G, I take this x1 and y1, the value of x1 will be taken from the same point from where we will take the value of y1. And the same way x2 and y2 will be taken from the other point, which should be the same one. If I apply the formula y2 minus y1, the y2 is minus 8, and then minus y1 is 7, divided by x2 minus x1. So x2 in this case is 1 minus, and the x1 is minus 4. That will become minus 15 over 1 plus 5, because minus times minus is plus, 1 plus 5 is 5, so that will be minus. In question number 2, the diagrams are given, the coordinates of the points are labeled in the question, in the diagram, as well as their coordinates are written in the statement. The points A01, B71, C60, D05 and E64, they are shown in the diagram, and you have to find the gradient of each of the line segment AB, AE, DC and DE. This is another way of asking to find the gradient of any line segment or any line. For example, if I take DC from here, so what you can see is D, the points D means the coordinates of the point D, they are 0 and 5, and C you can see is 6, 0. So the gradient again will be, if I take, in this case, okay, I change the order. I take this x1, and then definitely y1 will be from the same point, and take x2 from the point D, which is here x2 0, and definitely I will have to take y2 from the same point. It means x1, y1 I have taken from C, and x2, y2 I have taken from D. The formula says y2 minus y1. The gradient will be 5 minus 0, 5 minus y2 minus y1 over x2 minus x1, 6 हो गया. That will be 5 over minus 6. You can write this like this, minus 5 over 6. Negative sign will be written once, and you can write it in denominator or the numerator or just before the fraction. So this question is the same as question number 1, only the way of asking is different. In the question number 1, the points, the coordinates of the points were given. The same is the case here, but the diagram is shown in the question. Otherwise, question number 1 and question number 2, they are same. Question number 6, the points P, Q, and R, they have coordinates 6, minus 11, K, minus 9, and 2K, minus 3, respectively. If the gradient of PQ, now the gradient of PQ means the P is 6 minus 11 and Q is K minus 9. So the gradient of PQ, that will be minus 9 minus minus 11 y2 minus y1 over k minus 6. That will be minus 9 plus 11 over k minus 2, which will become 2 over k minus 2. I hope I'm clear about this one. Okay? Minus 9 minus y2 minus 1. And the second, that is equal to the gradient of PR. So the gradient of PR, for gradient of PR, we know P is the same 6 minus 11 and R is 2k and minus 3. So the gradient will be y2, which is minus 3 minus 11 over 2k minus 6. When simplified, that will become minus 3 minus minus plus minus 3 plus 11, that will become 8, positive 8, because the larger number is positive, over 2k minus 6. So in the question, it is given, it is stated that the gradient of PQ is equal to the gradient of PR. Means these two answers, they are equal. It's given in the question. If the gradient of PQ, that is equal to the gradient of PR, so means we will follow this statement, and that says both gradients with both gradients, the gradient of PQ and the gradient of PR, they are equal, so we will make them equal. That will be 2 over k minus 2 is equal to 8 over 2k minus 6, and that is given. It is given. You can write it is given because we are taking it equal, because in the question the statement is given there. So we will cross multiply and we will solve the equation so obtained to get the value of k. In this question, we have to find the value of k. If I cross multiply, because there is one fraction on each side, so if I cross multiply 8 times k minus 2, and that is equal to 2 times 2k minus 6. So when simplified, that will become 8k minus 16 is equal to 4k minus 12. 8k, I will shift 4k to the left side. That will become 8k minus 4k is equal to minus 12 plus 16. And 4k is equal to 4. And that will give me k is equal to 1. On the same straight line. Means they lie on the same straight line. So if they are collinear, the gradient of PQ, the gradient of QR, and the gradient of PR, they will be equal. If the points are on the same straight line, whatever the points you will take on the same straight line, the gradient will remain same. For any line, we need to find the gradient. So it doesn't matter what points we take from the straight line. So whatever 2 points you will take from the same straight line, the gradient will remain same. So that's why we can use this property, as it is mentioned or it is stated in the question that P, Q, and R, they are on the same line, they are collinear, means the gradient of PQ will be the same as the gradient of QR, will be the same as the gradient of PR. Means whatever 2 points we will take, the gradient will remain same. If I talk about PQ, the gradient will be minus 2 minus minus 3 over y2 minus y1, okay, na? And 3 minus 2. So that will be same if I take QR. That will be same as z minus minus 2 over 8 minus 3. Since they are on the same straight line, so their gradients will be equal. So this is another way of saying the same question as we did the previous one. In that question, in this statement was mentioned that the gradients are equal. This is indirectly stated that the gradient of each line segment made by P, Q, and R, whatever the segment, they will be equal. So when simplified, that will become -2 minus 3 means +3. That will become 1. 2 plus 3 is 1 over 1. 3 minus 2. That is equal to Z plus 2 over 8 minus 3 is 5. By cross multiplying, we will have Z plus 2 is equal to 5. And that will give us the value of Z, which is 5 minus 2, 3. So here the new thing is to know what is meant by collinear. In the topic coordinate geometry, this word is used to state that the gradients are equal. Question number 8. In the question number 8, the line joining the points A, which is 2t, and B, which is 7, comma 2t square plus 7, has a gradient of 2. Find the possible values of t. So in this case, as it is obvious from here, you can see the B has a quadratic expression 2t squared plus 7. So in this case, the equation formed will be a quadratic one. So in this case, the gradient of AB, when we say the gradient of AB, to that will be y2 is 2t squared plus 7, y2 minus y1, which is 3, over 7. X2 is 7 minus 2. So that is equal to 2, because it's given in the question. The gradient of the line joining points A and B, that is 2. So the answer should be 2. Now, in the next step, 2t square minus t plus 7, that is equal to 7 minus 2. 7 minus 2 is 5. This is dividing, and that will, when we will shift it to the right side, it will go and multiply to 2 on the right, because it's dividing on the left side. On the right side, it will multiply. So 5 will multiply to 2, and that will give us 10. 2t square minus t plus 7 minus 10 is equal to 0. So we have 2t square minus t minus 3 is equal to 0. We will solve this equation, this quadratic equation, to find the value of t. So this is a quadratic equation. Such questions are very much according to the Cambridge, because two concepts are being checked here: how to solve a quadratic equation and the coordinate geometry. Two concepts are involved here. So we can do, I think, midterm breaking, because if we multiply the first and the third term, we get minus 6t square. So 2t square minus 3t plus 2t minus 3 will give us midterm breaking. Now we will take t common, 2t minus 3 plus 1 common, 2t minus 3 is equal to 0. 2t minus 3 times 2t plus 1 is equal to 0. So 2t is equal to 3, or t is equal to minus 1. Hence t is equal to 3 over 2, or t is equal to minus 1. Question number 9, I just discussed. I will not do question number 9. This question number 9 is for you people to practice for this question. This is the coordinates of the vertices of a square A, B, C, D are A 0, 6, B is 2, 1, C is 7, 3, and D is 5, 8. So the part 1 is find the gradient of all 4 sides of A, B, C, D. It means you have to find the gradient of AB, BC, CD, and DA. DA, or you can call it AD. Because if this is a square and this is A, B, C, D, so we have 4 lines, 4 straight lines, A, B, C, D. So you will find the gradient of AB, you will find the gradient of BC, you will find the gradient of CD, and the gradient of AD, or you can call it DA. So means in this question, in this one part, actually you have to find 4 gradients. And the part 2 is, what do you observe about the gradients of the opposite sides of a square? So since we have not enough time, you will do this question number 9. So this question is basically first to find the 4 gradients, then you have to compare the gradients of opposite sides. In this case, AD and BC and AB and DC. Means you will do 2 types of comparison. One is gradients of AB and DC. Do you have any idea what will be there? Any guesses? What will be between the gradients of AB and DC? These 2 sides, these are the 2 opposite sides. And the other 2 opposite sides are AD and BC. Any guesses? What will be the result? What would be the observation?